So the purpose of this lesson is to explore binary code, to grow an interest in learning more about computer science. We're going to link it with the top of the year, place value, and things they already know in base 10, relate that to base 2, and explore coding on a computer, and then code some words ourselves. So base 10 works in tens, right? We know that. We're always grouping up groups of 10. So we're pretty good at that. That's what we practice with all the time. Whew. But what about base 2? Just look at this and just look at it for a minute and raise your hand if you see some observations about this. This is a place value chart for base 2. What are some things that you can observe about this? Kylie?
There's exponent.
Okay. Do we still have exponents on a base 10 chart? We just didn't show it on that one. They're still there. Yeah. Anybody else notice anything about this chart? Jordan?
It doubles.
Okay. Jordan says it doubles. Do you see any familiar words? What about here?
One's place.
One's place, two's place. So it still has place value, but it doesn't go up by 10 anymore. It goes up by 2 times 2. Base 2 kind of makes sense when you think of it that way, right? So when we're talking about base 2 or binary numbers, who remembers what that prefix bi means? Carter? 2. We can only use 2 different digits. We can only use zeros or ones. Now on base 10, we can use 0 through 9, so a lot more combinations right there. Base 2 binary is just zeros and ones, okay? But the position of their digits is kind of like base 10. They still have value based on where they are. Our first instinct might be to read this as 101, but that's base 10. So this is base 2. So this is not 101. This has a 1 in the 4's place, a 0 in the 2's place, and a 1 in the 1's place. So I add them together like expanded form. So 101 is really the number 5. Do we see it?
Yeah.
I know, it's kind of wild. So 101 base 10, that we would just look at that and we would say, a kindergartner could tell you that's 101. But base 2, that's really 5. So what form are we using here to figure that out?
Addition.
Which is, what do we use addition? What form do we use? Standard or expanded or written? This is just expanded form, right? And so they might not even realize they're working in an algorithm. A set of steps is all that is. So the more that we keep doing sets of steps in things, they build algorithms before they even realize that's what they're doing. Now we know that you can use zeros and ones. Binary means I'm just using zeros and ones. But what is it for? Why am I using it? Why do I even want to know about it? Okay, so this is it's about 4 minutes. And it's kind of mind-blowing. So before I start it, the goal is not to fully understand maybe all the technical things that you're about to hear in this video, right? But it's just to kind of open your brain up to hear more about what it is. But they're going to throw a lot of vocabulary at you and a lot of cool things. But don't panic. You're not getting quizzed on any of that. And that's not the real point of it. It's just to kind of let you learn more about this world that's out there, okay? So what do you think? Any just takeaways? What did you learn? Anything, or did anything stick out to you as like, whoa, that was cool? Jordan?
I didn't know that binary coding is used in like sound.
Yeah.
Sound. I mean, it's crazy. Yeah.
Sound. Anything else?
I thought it was cool how it's like there's so many little pixels on one screen.
Yeah, so Sophia, that was what, Sophia is like one of our class artists, and she thought that was the most interesting. She was like, all these different things to show the color green or to show this shade of red, right? So lots happening with just zeros and ones. Only things that are used, zeros and ones. And the order that you put them in or how they're grouped makes all the difference for how that's working. All right, let's do it ourselves. Let's take those zeros and ones, those bits and bytes, and let's code something ourselves, okay? We are going to have 3 different colored beads, a necklace, an alphabet, and you're gonna pick a word, okay? That's what we're gonna have moving forward. So, here's a binary alphabet. This one's just using capital letters today. That's what we're going to use. What do you notice about each letter? How many numbers does it take to represent each letter? Phoebe? 8. And we said that 8 bits made a byte. So every one of these letters is represented by 8 numbers. How would you feel if you had to write your name with this? It would take us so long. What if you had to write a paper for Miss Van Hook using this? No.
I want to actually try and do my name.
Yeah. So every letter is 8. So keep that in mind. And I'm going to make you keep your words to 6 letters or less. Or else you'll be stringing all day long, right? So keep that in mind when you're thinking of what word you want to code in a minute. We're going to keep it to 6 letters or less. Some of you would pick a 15 letter. I know you would. And we can't sit here all day for that. I think it's great to take something that you might think is only computer or might think is too hard for someone who's 8, 9, 10 and make it a physical activity, make something that you can do out of it, make it more relevant to them. They might not understand coding yet, but they can see a sequence or a pattern and do something with it and make something fun out of it.